The purpose of this section is to classify angles as either acute, obtuse, right, or straight. Use angle relationships to find missing angle measures. Identify angles pairs formed by a transversal. Use knowledge of angle pairs given a transversal to find missing measures. So first we'll just review really quickly what certain types of angles are. An acute angle is less than 90 degrees. An obtuse angle is more than 90 degrees. A right angle is equal to 90 degrees. And a straight angle, which is really just a straight line, is equal to 180 degrees. So if you scroll down here, you can just very easily classify the angle types. This is acute, right. Angle 1 would be obtuse. Angle 2 would be acute. Complementary angles are when you have two or more angles whose sum is 90. So check the three examples below, see if these are acute or are complementary, and say yes or no. Pause the video, press play when you're ready. So these two examples are yes. If you add them up, they add up to 90. This example is no. If you add them up, they add up to 80. So these first two examples, you can find missing angles pretty easily because this angle right here, they form a 90-degree angle. You can just subtract 35 from 90 to get 55 degrees. Same thing over here. It tells you they're complementary, so it's saying that they would add to 90, so you can just do 91 minus 60, and you get 29 degrees. These examples down here, you probably want to approach using an equation. So you have this angle right here, which is x. This angle right here, we can see they're complementary because they form a right angle, so that means they're going to add up to 90. So I could add the red angle and the blue angle, and they would add to 90. If I keep going, I'd get 2x plus 30 equals 90, 2x equals 60, x equals 30. Try that same approach with this problem over here. Pause the video, press play when you're ready to check your answer. So in this one, you know that one angle is y, one angle is 2y. If we add them up, we get 3y, and since they're complementary, they're adding to 90. You end up with y equals 30. On both of these, one thing I forgot to do is actually to go back and find the missing angle measures. It wasn't really asking for x or y, so here, this angle is 60, this angle is 30. Over here, this angle would be 30. This angle would be 60. Supplementary angles are just two or more angles whose sum is 180. It's important to know that that's also a straight line, so if you see two angles forming a straight line, you would know they equal 180. So again, pause the video for these three examples right here. All you're doing is saying yes or no. Are they supplementary or not, based on do they add up to 180? You could probably also find the two missing angles here. Press pause and hit play when you're ready to check your answers. So again, the first and the third are both yes, they add up to 180. This one adds up to 160, so it's not. If this forms a straight line, they need to add to 180, so the missing amount is 50. Same thing here, if these add to 180, the missing amount is 70. For these two examples here, you're going to set up an equation knowing that in both cases the angles are supplementary and solve to find the measure of both angles. Keep in mind that here you're not just finding the measure of x, but you're actually finding how much each angle would equal. Pause the video after you solve these two questions. Press play when you're ready to move on. So on the first example, you just take your two angle measures, which are 3x and 6x, add them up, and they add to 180 because they're supplementary. Combine like terms and solve, you get x equals 20. So then if x is 20, the measure of angle A would be 60, and if x is 20, the measure of angle B would be 120. And that makes sense because if you add those, they add up to 180. Same idea in this one, you take angle x plus 20, add them up, they add to 180, combine like terms, you get x equals 80, so then that would be 80 and that would be 100. They do add to 180, and yes, the picture is backwards, I just put the things in the wrong place. Technically, that 80 should be over here and the 100 should be over here if the picture was accurate, because obviously this angle is obtuse and that angle is acute. So down here, adjacent angles are angles that are next to each other and they share a common ray. Remember, an array is, it has one endpoint and then goes on forever in one direction. So down here, the two adjacent angles would be angle ABD. You have to name your angles in the order that they occur. And angle DBC are adjacent. And their common ray is right here, the ray BD. And when you name that, you name the endpoint first with the ray symbol on top. And then the vertex of that picture above would be B, because it's kind of like the corner point or the end point. The vertex can also be described as the end point of a ray. Vertical angles are two angles opposite each other, formed by intersecting lines. So to have vertical angles, you need intersecting lines. And the important thing about vertical angles is that they are congruent, meaning they have the same measure. So if you knew the measure of one angle, then any angle vertical to it would also have the same measure. So in this picture here, angle D and angle B are vertical. Actually, I shouldn't have measure there. So just angle B and angle D. Now their measures would also be congruent. And then angle A and angle C are vertical. So just for example, if you knew that the measure of angle C was 30 degrees, then angle A would also be 30 degrees because they're vertical. And then not only that, but because this forms a straight line, you could find angle B to be 150 because they add to 180. And then D would also be 150. So down here, you're going to use the fact that vertical angles are congruent to find the missing measure. So here you're going to find X, and here you're also going to find X. Pause the video, press play when you're ready to check. So this one's very straightforward. Here you have a 50-degree angle. X is vertical to it, so it would also be 55 degrees. Here, I kind of highlighted that one in blue and that one in red. They are vertical, so because they're vertical, they are equal. So I took the red angle, which is X plus 12, set it equal to the blue angle, which is 25, and solved for X. So X equals 13. So next we're going to be talking about special types of angle pairs that are formed. So first we have to talk about what parallel lines are. This year we learned that parallel lines have the same slope, which is important algebraically. But in geometry, what's important about parallel lines is that they never intersect, which is something we've always known about parallel lines. A transversal is a third line that intersects parallel lines. So before you can even have a transversal, you would need parallel lines, and then if a line intersects both of them, you have a transversal. When parallel lines are intersected by a transversal, 8 angles are formed, and there are 4 pairs. Each pair is congruent, meaning they have the same measure. So in this problem right here, say that's line A and line B. Lines A and B are parallel. That would make line C the transversal because it's intersecting the 2 parallel lines. And you can see the 8 angles that are formed. So the 4 pairs are listed below, and we'll talk about those. So alternate exterior angles. So alternate means opposite, exterior means outside. So if we look at the parallel lines, there are 4 angles that are outside the parallel lines. 8 and 7 are outside, 2 and 1 are outside. This is kind of the inside space of the parallel lines. And then alternate means on the opposite side of the transversal. So if here's the transversal, and we're only looking at 8, 7, 2, and 1. 8 and 7 are on opposite sides. 2 and 1 are on opposite sides, but you can see 8 is obtuse, 7 is acute, 2 is acute, 1 is obtuse. So we're looking for the ones that have the same measure. So angle 1 and angle 8 are alternate exterior. They are on opposite sides of the parallel lines and outside, opposite sides of the transversal and outside the parallel lines. Angle 2 and angle 7 are also alternate exterior because they are outside the parallel lines and on opposite sides of the transversal. So angles 1 and 8 would have the same measure. Angles 2 and 7 would have the same measure. Corresponding angles are two angles that would land in the same spot if you could slide one parallel line on top of the other. So if you could take line A and slide it up and try to envision which of these four angles would land on top of these four angles, those would be your corresponding angles. So angle 3 and angle 7 are corresponding because they're in the same spot. Angle 1 and angle 5. Angle 2 and angle 6. And angle 4 and angle 8. And each of these pairs, 3 and 7, 1 and 5, 2 and 6, 4 and 8, they would have the same measure as each other. Alternate interior angles are angles that are this time are going to be inside the parallel lines on the opposite sides of the transversal, but also have the same measure. So 6 and 3 would be alternate interior. And if you go back up, 4 and 5 would also be alternate interior. And again, these two would have the same measure, these two would have the same measure. Vertical angles we've already talked about, but they're still formed by a transversal, so 8 and 5 are vertical, 7 and 6 are vertical, 4 and 1, 2 and 3, and we already know that they have the same measure. So it was 8 and 5, 6 and 7, 2 and 3, and 1 and 4. The other thing I didn't list here, but that's also formed, are supplementary angles. So you can see, like, there's a straight line right there, so 3 and 4 would be supplementary. 3 and 1 would also be supplementary. So there's various supplementary angles there as well. So in this type of problem, we know that, and I'll call this angle 7, so that's the only number missing. So we know angle 7 is 60 degrees, so because of that, we could get angle 6, which would be also 60 degrees, and that's because they're vertical. And then once you know 6, you could also get 3, which would also be 60 degrees, and the reason for that would be their alternate interior. You also could have gotten 3 as 60 because it corresponds to 7. That would be another reason. Then you could also get angle 2, which is also going to be 60 degrees. A couple reasons for that. You could say it's vertical to 3, it's corresponding to 6, or it's alternate exterior to 7. So a variety of reasons to get those angles. So we have these ones. So then if we want to find one of either 8, 5, 4, or 1, maybe with 8 you could look and see that these are supplementary, so they have to add to 180, so 8 would be 120. You could have also done that same idea, supplementary idea, here. Or you could say these are the same because they're vertical. And then you could say 4 and 5 are alternate interior, so 4 would also be 120. But 4 is also supplementary to 3 or 2, so they'd have to add up to 180 anyway. 4 also corresponds to 8, so they have to have the same measure. And then 1 would also be 120. It could be because it's vertical to 4, it's supplementary to 3 or 2, it corresponds to 5, and it's alternate exterior to 8. So given this one angle measure of 75, you're going to find the measures of angles A, B, C, D, E, F, and G. Pause the video, press play when you're ready to check your answers. So angles A, D, and E would all be 75 degrees, while B, C, F, and G would all be 105. There's a lot of different reasons why that would happen. So if you have this, say they're supplementary, these are vertical, these are alternate interior, these are alternate exterior, these are vertical. It's a whole variety of reasons as to why you get these answers, but that's what you're going with.